Let's start with Uranus, the planet that simply refuses to stand upright. Most planets rotate with a slight tilt, like Earth, which is angled at about 23.5 degrees. Uranus? It's tilted a staggering 98 degrees. That means it literally rolls around the sun on its side, like a cosmic bowling ball, one that somehow still manages to orbit gracefully with the rest of the solar system. This bizarre orientation leads to some of the most extreme seasonal changes of any planet. For decades, one pole faces the sun continuously, bathing in non-stop daylight, while the other is plunged into a frozen, dark abyss. Then, half an orbit later, they swap places. Imagine living in 6 months of unrelenting sunshine, followed by 6 months of pitch-black night. No wonder Uranus has earned a reputation as the weird kid of the solar system. But that's exactly what makes it so fascinating. Contrary to popular belief, Uranus still rotates in the same direction as most other planets. It's just doing it while tipped over. Scientists believe a massive collision with an Earth-sized object in the early solar system may have knocked Uranus sideways, forever altering its spin and its destiny. Now let's talk about Neptune, often overshadowed by its bigger siblings like Jupiter and Saturn, but equally deserving of attention. Some people casually call Neptune a blue Jupiter. That's like saying a dolphin is just a wet cat. The comparison doesn't hold up. Neptune may be a gas giant, but it's in a category of its own, an ice giant. It contains a higher proportion of elements like water, ammonia, and methane ices, giving it a denser composition and that stunning sapphire hue. And while Uranus may be the sideways wonder, Neptune is the storm champion. It boasts the fastest winds in the solar system, reaching up to 1,300 miles per hour, 2,100 km/h. That's faster than the speed of sound on Earth. Imagine standing in the middle of a hurricane that wraps the planet in a day. That's Neptune's normal weather. Its largest storm system ever recorded was dubbed the Great Dark Spot, akin to Jupiter's Great Red Spot, but darker, faster, and more short-lived. Neptune's dynamic atmosphere, shaped by internal heat and frigid temperatures, creates turbulent and unpredictable climate patterns, like a cosmic version of wild mood swings. Despite their differences, Uranus and Neptune share some key similarities. They're both rich in methane, which absorbs red light and reflects blue, hence their deep azure appearances. They're both cold, very cold, and they both have systems of faint rings and moons, including some bizarre and irregular satellites. One of Uranus's moons, Miranda, features cliffs taller than Mount Everest, and jumbled terrains that look like nature's attempt at abstract art. Meanwhile, Neptune's largest moon, Triton, is a frozen enigma that orbits backwards, a clear sign that it was likely captured from the Kuiper Belt. But here's what's most tragic: we barely know them. Since their discovery, only one spacecraft has ever visited Uranus and Neptune, NASA's Voyager 2 in the 1980s. In just a few brief flybys, it gave us the only close-up images we have of these mysterious worlds. No probes, no orbiters, no rovers, just snapshots. In a time when we dream of colonizing Mars and setting foot on the Moon again, the outer giants remain largely unexplored. Yet scientists believe that these ice giants may hold critical clues to understanding how planetary systems form and evolve, both in our solar system and in others. In fact, recent exoplanet discoveries have shown that Neptune-sized worlds are the most common type of planet in our galaxy. By understanding Neptune and Uranus better, we might unlock the secrets of entire planetary systems light years away. So maybe Uranus isn't just the solar system's punchline, and Neptune isn't just a blue gas ball. Maybe they're reminders that diversity is the rule, not the exception, even in space. And maybe, just maybe, it's time we went back to these frozen giants and gave them the exploration they deserve.